I want to spend a few more words on the concept of the path of least resistance. As we've seen before, the current tends to use the path where the resistance is the least. We can see an example of this in the two equations that we have just calculated. These ones. Assume for a minute that R1 is 2 times as big as R2. So R1 equal 2 times R2. If we replace R1 in both these equations, we get that I1 is equal to I path divided by 3, and I2 is equal to I path divided by 3 multiplied by 2. As you can see, 2/3 of the current went into the smaller resistor R2 and only 1/3 went into R1. In other words, because R1 is twice as big as R2, the current in R2 is 2 times the current in R1. We can use an hydraulic example to qualitatively explain these results. An equivalent hydraulic circuit for this current divider could be a tube carrying some water that splits into two subtubes T1 and T2. The subtubes are not of the same size. On the contrary, because T2 is representing a resistor that is half the size as the other, the subtube will be twice as large. It is not hard to see how, in the scenario that I've just described, most of the water will prefer to flow into T2, just as 2/3 of the current prefers to flow into R2 rather than R1 in the electrical circuit. Finally, let's look at the corner case. Imagine that R2 is equal to 0. That is, the resistor is replaced with a short circuit. Or in the case of the hydraulic circuit, the second tube is replaced by an infinitely large tube. In this case, the equation tells us that no current will flow into R1, and that all the current will go into R2. A short circuit will therefore deprive the circuit of all of its current and cause a large amount of current to concentrate into a tiny wire. I1 will be 0, and I2 will be equal to I path. Note that not only I2 will be equal to I path, but if you consider this specific circuit, the value of I path will also become infinite, because now you are applying a voltage of a certain value, V path, across a resistor equal to 0. So if you use Ohm's law, you can calculate that the current will become infinite. In real circuits, the current cannot really become infinite, but it will definitely become really large. That is why short circuits are so dangerous. They generate large current in small areas, and they often not only prevent the circuit from working as intended, but they can also start a fire and destroy the circuit.